Jai Hind. Welcome to the course Network Analysis and Synthesis, and today I am going to discuss about the graph theory. So, learning objective of this topic, graph theory, is what is the importance of graph theory in network analysis. In your BTech first year course, you have come across the various techniques to solve a network, that is the node and mesh analysis. But when the given network is fairly complicated and it is very difficult to apply the nodal and mesh analysis, in that case we follow the graph theory. So in graph theory, basically a computer method. We use some matrices and write the matrices and enter the matrices into the computer to get the solution of the network. So we'll discuss in detail how we'll carry out the network analysis using the graph theory later on. Then the second is how we'll do it. So a network is given, and what we do, we draw the graph of a network, and there are some definitions. Some of them are what is the planar and non-planar graphs, isomorphic graphs, then tree and co-tree. So basically a graph is given, then we select a tree and write some matrices on the basis of given tree. So these are the some terminology that will come across this topic. We'll discuss in detail each one. So these are the then the cut set and tie set matrices, incident matrices. So these are the matrices we will discuss in the graph theory, and the last is duality and loop and nodal method of analysis using the graph theory. So these are the learning objectives related to the graph theory. So we'll take one by one. So first and foremost, we just discuss some terminology that we will use in graph theory. So what are those? So first is, what is graph? So a graph is defined as a collection of branches and nodes in which each branch connects two nodes. So a network is given, and thus we identify the number of branches and number of nodes, and we just we draw the line representation of a given network. So what is branch in graph theory? So when each network element replaced by a simple line segment called a branch or an edge. So next term is path. What is the path? So path is a sequence of branches traversed in going from one node to another node is called a path. Then what is connected graph? So if there exists at least one path from each node of a graph to every other nodes, the graph is said to be connected, otherwise the graph is disconnected. So we'll discuss all these definitions by taking some examples. Then what is isomorphic graph? So two graphs are said to be isomorphic if there is one-to-one correspondence between the branches and nodes of the two graphs. So two graphs are given. If there is a one-to-one correspondence between the nodes and branches, then these two graphs are said to be isomorphic. Then what is oriented graph? So a graph whose branches carry orientations is called an oriented graph, and by convention the tail of the arrow of the current reference is put at the plus sign of the voltage reference. So a network is given. So in network there is the active sources, there are passive sources. Passive sources are replaced by the line segment, and the active sources, there may be voltage source, there may be current source. The voltage source may have the polarity, so that branch has some orientation. Current source has some direction, so that branch has some orientation. So depending upon the direction of the current or voltage, we orient the branch. So convention, generally we follow this. So suppose this is element, and current is leaving the plus and entering the minus. So this is the origin. So this is the element of a network, and this is the element of a graph. So this element in the network will be represented by this element in the graph. So this is the oriented graph. This segment has orientation, and how will do it? On the basis of the what is the direction of the current in that branch. Then the another term is what is degree of the node. So number of branches incident at a node on a graph is called the degree of node. Then simple, what is simple node? So a node of degree 2 or more is called a simple node. Then terminal node, so a node of degree 1 is called a terminal node. So if there is incident of only one branch, then that node is called terminal node. And if there is 2 or more branches are incident on a particular node, then that node is called simple node. So these are the definitions of degree of node, simple node and terminal node. Now what is subgraph? So a subgraph of a graph G is a graph whose branches and nodes form a subset of the branches and nodes of the graph G. So a original graph is G, and you are required to draw the subgraph. So the elements, the branches and nodes of that subgraph will be the branch and nodes of the original graph G. So it is a subset of original graph G. What is proper subgraph? So a subgraph of G is the original graph, is said to be proper subgraph of G if it does not contain all the branches and nodes of the original graph. So original graph has branches and nodes, and we take some nodes and branches and draw a graph. That graph is called subgraph. A spanning subgraph. So if a graph contains all the nodes of a graph G, it is called a spanning subgraph of G. So if a subgraph contains all the nodes of the graph G, it is called a spanning subgraph of G, or it is also called a tree of the graph. Then planar graph. So a graph is said to be planar if it can be drawn on a sheet of paper such that no two branches cross each other. Otherwise, the graph is said to be non-planar. And complete graph. What is complete graph? So a graph in which there is one and only one branch between every pair of nodes is called a complete graph. So number of branches in a complete graph having n nodes is given by this expression: n into n minus 1 upon 2. So how many number of branches, that will be given by this expression. So these are the some terminology that are being used in graph theory, starting with what is the graph. It is collection of branches in nodes. What is branch? What is path? What is isomorphic graph? What is connected graph? So on. So all these things we can try to understand some examples. Suppose there are two networks as given, okay, and you are required to draw the graph of the network. So we can see that how many nodes are there. Then this is one node, two node, three node, 4 node, and 5 nodes. So we can see here is one here and here is one. So branches, so we just encircle, and node we encircle and branches we write in brackets. Okay. So this is the network, given network. Given network, okay, and you are required to draw the graph of the network. So first and foremost, we have to identify how many nodes are there and how many branches. So our nodes are 1, 2, 3, 4, 5. Okay. So just number it. It is 1. This is 2. This is 3. This is your 4. And this is your 5. So we can see that this node, this and this same node. This is also 4. Okay. Same potential. Okay. Equipotential surface. Same potential. So this is 4. So branch 1 is connected between 1 and 4. So just simply what we do, we just connect this way. And this is your branch 1. Branch 2 is between 1 and 2. So branch 2 connects node 1 and 2. So this is 2. Okay. Branch 3 connects 2 and 4. Branch 4 connects 2 and 3. And branch 6 connects 3 and 5. And branch 5 connects 4 and 5. Okay. So this is the given network and this is the graph of the network. Okay. So what is the definition of graph? The graph of a network in which each branch connects two nodes. Okay. And the network is not oriented. So this graph is also not oriented. So this is not a oriented graph. This graph is not oriented, but this is a connected graph. Connected graph. Why it is connected? We can go from each node to every other nodes. We can go from the 1 to 4. We can go using the branch 1. Using branch 2 and 3, we can go from 1 to 4. We can go 1 to 4 using branch 2, 4, 6 and 5. 2, 3. So there are 3 paths. We can go from node 1 to node 4. Okay. So what is path, what is graph, what is branch, and what is connected graph? So this is clear. And what is oriented? This graph is not oriented. Not oriented graph. Because the network is not oriented. We have not taken the reference direction of the current. We have not taken. So this graph is not oriented. This graph is connected because we may be able to go from the each node to every other nodes. Look at this network. So we can see that this is one node 1. This is node 2. Okay. This is node 3. This is node 4. And this is node 5. And what are branches? Branch number 1, branch number 2, branch number 3, branch number 4, branch number 5, and branch number 6. So in this network also there are 5 nodes and 6 branches. Draw the graph of the network. So we can draw. So mark here. This is your 1. This is your 2. can mark. Okay, we can mark 3. We mark 3, then 4, and then 5. So there are 5 nodes. Now branch 1 is connected between 1 and 2 because same node, same node. So this is equipotential surface, same node. So 1 is, this is 1. Branch 2 is also between 1 and 2. So it is also from 1 and 2. This is 2. Branch 3 is also in between 1 and 2. Okay. Now there is no connection between 1 and 2, 1 and 3, and no connection between 2 and 3. So we can see that branch number 4 is in between 3 and 5. So it is branch number 4. Branch number 5 is between 3 and 4. And branch 6 is 4 and 5. Okay. So this is the graph of the network. This is graph of the network. Okay. Can you anybody tell whether the graph is connected or disconnected? We may able to go from node 1 to node 3? No, we cannot go. From 2 to 3, 2 to 5, 2 to 4, or 1 to 3, or 4 or 5. We cannot move from 1 to 3, or 1 to 4, or 1 to 5. So this graph is disconnected graph. This is called disconnected. Disconnected graph. Okay, and not oriented. Not oriented. Not oriented. Okay. So we can understand what is disconnected graph, what is connected graph. If there exists one path between every node to other nodes, then the graph is said to be connected. Otherwise disconnected. So this is the disconnected. We cannot go from 1 to 3, or 2 to 3, or 2 to 5, because there is no path. Then there is no path between 1 and 3, or 1, 2 and 3, and 2 and 5. So this is also the graph of this network, but this is disconnected, and this is the connected graph. So we can understand what is the connected graph, what is the disconnected graph. And as of now, it is these two graphs are not oriented. Okay. Now try to understand what is isomorphic graph. So we have, in the definition we have seen a graph is said to be, two graphs are said to be isomorphic if there exists one-to-one correspondence between the branches and nodes of the two graphs. So look at this graph. This is graph 1. This is graph 1, and this is a graph 2. Graph 2. Can we say that these two graphs are isomorphic? So for that we have to check all the nodes and branches of this. Suppose in this is the we can say there are 1, 2, 3 and 4. 4 nodes. 4 nodes. And how many branches? 6 branches. In this graph also 4 nodes and 6 branches. Okay. Now we have to check whether there is one-to-one correspondence between the nodes and branches. So look at the branch number 1. So this is the branch number 1 and it is between 1 and 4 in this graph number 1. So in graph number 2, this branch number 1 is in between 1 and 4. We can see. So the branch in graph number 1 is in between 1 and 4 and branch in graph 2 is also in between 1 and 4. Now look at the branch number 2. So branch number 2 is between node 1 and 2. Here the branch 2 is in between node 1 and 2. 3 is between 2 and 3. 3 is between 2 and 3. 4, this is the 4. 4 is between 3 and 4. 3 and 4. 5 is 1 and 4. 5 is this 5 is 2 and 4. So this 5 is 2 and 4. This. Then 6, 1 and 3. 1 and 3. So we can say that this graph 1 and graph 2, they are isomorphic. The presentation is different, but they are the isomorphic, same, because there is one-to-one correspondence between the branches and nodes of the two graphs. So this graph 1 and graph 2 are isomorphic. Clear? What is isomorphic graph? This is, we can also check this one. 1, 4, 1, 4, 3, 4, 4, 3, 4, 1 and 3, 6, 1 and 3, 6, 1 and 3, 6, 3 and 2, 3, 3 and 2, 3, 2 and 4, 5. So this is, so same graph. This is the same. This is all the graphs are, I think, same. Check this one. 1 between 1 and 4. 2, 1 and 2. 3, 2 and 3. 6, 1 and 3. 5, 2 and 4. And 4. It is between 3 and 4. So all four graphs are isomorphic. All 4 graphs are isomorphic. So if the network is given, network is same. So the graph of the network can be drawn in 4 different ways. All are the same. Okay. Now there is another planar and non-planar. We also discussed what is a planar and non-planar. Non-planar graph. A graph is said to be planar if we draw on a sheet of a paper such that no two branches cross each other. So can anybody tell whether the graph 2 is can you say the 5 and 6 they are crossing each other? Five and 6 are crossing each other? No, they are not crossing. We can draw this. We can draw this 4 and 5 like this. So 5 is between 1 and 3. So this is 1 and this is 3. So we can draw this 5. And 6 is 4 and 5. So 6 and 5 and 6 branches are not crossing each other. So this is planar graph. So we stop here. In the next class, we will discuss remaining portion of this unit. Jai Hind. Thank you very much.